Okay, welcome. This is going to be such a fun module. We're talking about reactions. We're talking about the Reactivity Series, which is a whole bunch of things. So let's get into the first experiment. So here we go. So we've got a gray-black mixture over here. Okay, and this gray-black mixture is a combination of magnesium, that would be the gray substance, and we've got a black mixture called copper oxide. Now what we are trying to achieve in this experiment is by applying a lot of heat, as you can see at the bottom here with the Bunsen burner, we are going to try to put this magnesium, or put a lot of these magnesium atoms, we're going to try and put them in place of this copper. So we're kind of trying to substitute these two. It's called a displacement reaction because it displaces out the copper and fills it with the magnesium. Now, when this reaction actually happens, what happens is it's like an explosion. So it's like, so basically, let's just copy across this. Okay, let's not take those. Let's copy across this little guy. So this thing here is it's a massive explosion. Okay, because this heat applies. What actually happens is there's so much energy that is released when this actually occurs. But what happens at the end, once this is cooled down, what's going to happen is that magnesium oxide is going to form, and we are going to be left with copper. So what you'll start to see at the bottom of this crucible is a whole bunch of copper, okay, copper solid, and magnesium oxide, like we've learned in previous modules, is this gray, okay, let's get it better, it's this gray solid, it's like a gray powder. So why do we do this? Well, it's used to extract pure metals like copper. So most of the time in the environment we find metals as metal oxide. So we can see here this is copper oxide. Another example would be iron oxide. And what we're trying to achieve is we're trying to extract the pure metal, the atom by itself, iron or copper in this case. So this is our first experiment that we are talking about. But the knowledge and the theory behind displacement reactions comes from the Reactivity Series. Now, the Reactivity Series is basically a whole bunch of elements over here that are in this list. So here's the list from top to bottom, okay? The decreasing reactivity, what does that mean? It means that if the element is above another element, it will cause a displacement reaction. If it is below that element, there will not be a reaction. Now let me give you an example. Let's look at this example we have over here. We have magnesium and copper. Let's go and look at these two on the Reactivity Series and take out our highlighter. Okay, let's get a nice yellow highlighter. We've got magnesium over here, and we've got copper down here. Can you see that magnesium is above copper? That means if you look at your equation, we've got magnesium which is above copper. That means that it is a reactive substance, it's more reactive than copper, and it will therefore replace copper. If I had to do this the other way around, let's say I had magnesium oxide and I had copper over here, and I applied some heat to these substances, and I wanted to replace the copper with the magnesium so that I could just be left with magnesium as a solid, right? This does not happen. And the reason it doesn't happen is because magnesium is higher than copper. And you can't then take copper and replace it with magnesium because copper is below magnesium. So you can actually do a lot of different experiments here as long as the atom that you're trying to replace or the element that you're trying to replace is above on the Reactivity Series. Okay, so let's do another example, and let's keep this Reactivity Series quite close by. So let's do a hashtag number 2. Okay, let's say we've got magnesium plus zinc oxide. Okay, now what are we trying to achieve here? Think about it. We're trying to replace the zinc with magnesium so that we can be left with just the zinc. Now let's see if this is going to happen. Well, magnesium's over here. Where is zinc? Zinc is over here. This is going to work. So magnesium is going to be replaced, and what we're going to be left with is we're going to be left with zinc plus, remember, the magnesium is taking this spot, magnesium oxide. So this is what would happen in this example. Let's take another example. Let's take hashtag number 3. Let's take carbon, which is a very common element found in the environment, and let's take copper oxide. Now what are we trying to do? Remember, we're trying to replace the copper with carbon, and so that we can be left with pure copper. And what's going to happen here is we're actually going to form carbon dioxide. Now this is not a balanced equation. Think about it. Well, we've got 2 oxygens on the right hand side, so we'll put a 2 over here, and that will be nicely balanced. So these are 3 examples of a reactivity displacement reaction with the reactivity series. And I think let's do one more. Let's talk about iron. Like, what if we wanted iron? Like, iron is such a common substance used in the manufacturing businesses and such. So let's take iron oxide that we find in the environment, and we take carbon. What's going to happen again is we are going to replace that iron with the carbon, and we're gonna produce pure iron. And of course, when we've got carbon and oxygen together in this kind of reaction, we produce carbon dioxide. This is not balanced. Let's put a 2 in front of there and a 2 in front of here, and there we go. We have our balance. So you're gonna have to go and memorize this reactivity series over here. Some of these equations will pop up in your exams, and yeah, this is part 1 of the reactivity series. We will be going into a little bit more knowledge about these things. It's changed my camera. That was part 1. I hope it was enjoyable. I hope it was interesting, and I'll see you in part 2.